Welcome back, everybody, to the final part of geometric mean in right triangle similarity. This is a tough concept, okay, but this is going to be the last breakdown concept summary before we get into some examples, and I'll kind of teach you how we approach problems as we see them. Now, the concept summary. The first thing we're looking at is S1 over A. So we have all these labeled here, and you're like, what the heck is this? So S basically stands for short side, L stands for a longer side, and then we have H as hypotenuse. Not a super big fan of this labeling. You're like, what the heck? You're the one that labeled it. I know, I get it, but this is how you'll see it in your book. So I just want to be like, okay, if you see it in your book, this is how you approach it. A stands for altitude. H stands for the hypotenuse of the big triangle. A stands for altitude. L1 stands for the leg 1 of the big triangle. L2 of the big triangle. So those are the legs of the big triangle. S1 stands for a secondary leg, so a short leg, and then we have a short leg, or a side, I should say. That's a side 1 of the small triangle and side 2 of the medium triangle, okay? Now, what I like to do is I like to draw these other shapes in here, not other shapes, but the outlines of the small triangle, okay, just to help us out, see it a little bit better. Okay, and I think this will help us too. Okay, so go ahead and I would make sure you do this. All right. So that kind of helps us see the 3 different triangles. Now, what are we talking about here? The first one is we're comparing S1 over A. Anytime we're comparing S1 over A, okay, notice how both of those segments belong to this small triangle. S1, this side, and A, this side, okay? So you're comparing, those both belong to the small triangle, okay? Now, that's the short side over the long side of the triangle. Okay, now we always have to look for what sides do they share. Is this shared with any other triangle? Is this side shared with any other triangle? It is not. Is this side shared with any other triangle? If it's not, then we're not making a good comparison. But it is. It's shared with the purple triangle, the medium triangle. This altitude is shared with the medium triangle. Look there. Okay, so that's good. We're making a valid comparison because it has a shared side. If we don't have a shared side, we can't make a valid comparison. So we have medium, and this time we're comparing the short side. Okay, what's the short side? A. A is the short side. And then we have its long side is S2, and that's not important. But the important thing is we need to have this geometric mean established. That's very important. Okay, now, anytime you're comparing the short to long side, you're always going to be comparing the small and medium triangle. And anytime you're comparing the small and medium triangle, you're always going to be comparing the short and long side. These go together. You can't compare the small and medium triangle without also comparing their short and long side. And it's because they don't share a hypotenuse. They don't have a combined hypotenuse, okay? So anytime you're comparing small and medium, you're always going to be using the short and long side of those triangles. You're not going to be using the hypotenuse. Now, if you are seeing that a hypotenuse is given, then you're going to be comparing the big triangle. So I drew the big triangle there in yellow. Last time I used blue, so I don't know why I changed, but this time we're using yellow. So this is the big triangle. Okay, the big triangle. Now, if we're comparing the big triangle, okay, that means we're using the hypotenuse. So as you can see, H is the hypotenuse, and we're doing it over L1. L1 is the short leg. Now we need to see which of these legs, the hypotenuse will never be shared. The hypotenuse of the big one is never going to be shared by one other triangle because it's the biggest side. It's the biggest side in the whole thing. So the smaller side has a chance, though. The smaller side, we're going to see what's shared with that. Okay, so we're looking here at the small side, the short side of the big triangle, and we see that it's a side of the small triangle. So it is a side of the small triangle. Which side is it? Well, it is the hypotenuse. L1 is the hypotenuse of the small triangle, okay? So we made a valid comparison. Why? Why did we make a valid comparison? Because we have a geometric mean. L1 is the denominator of one side, L1 is the numerator of the other side, okay? So now we also have to compare the short side of the small triangle, and that's S1, okay? So we have a geometric mean, it's valid. Now, there's another way we can compare the big side, okay? That was comparing the hypotenuse to the short side, okay? Anytime we're comparing the hypotenuse, there's always going to be two different types of ways we can compare it. It all depends on what's given. So here we have the big side, the big triangle given again, but this time it's the hypotenuse over the long side, okay? The hypotenuse over the long side, and I highlighted that because it's part of the big triangle. So now we're looking, okay, the long side, which side shares that? Where is this a shared side? L2. So we're going to look at L2 here, and we're going to see, is this a shared side? Yes, it is. L2 is also part of the medium triangle. So here we have the medium triangle is being shared. Okay, sorry, I forgot to underline this. So the medium triangle also has a side of L2, and that's its hypotenuse. And it's important that it's hypotenuse because remember, hypotenuse over long on the left, hypotenuse over long on the right. We have to make that comparison. And that's going to be S2 is the long side. We can make this comparison, we know, because we have a geometric mean. L2 is the denominator of one side and the numerator of the other side. So again, if we have a hypotenuse given, we know we're going to be comparing big to small or big to medium. If we don't have a hypotenuse given, but instead we're comparing the short to long side, or comparing the small and medium triangles. That's going to be the case every time. Let's go ahead and look at example 1. Example 1, we have certain piece of information given. Let's see how much and what we have. So first, let's highlight our triangles, our 3 triangles. We have our big one. Here's our big triangle. Okay, let's go to the medium. Medium is here. And then we have our small guy, okay, here. Sometimes it'll be hard to differentiate which one's the small, which one's the medium. Experiment with it, but remember, you can only do it if you can form a geometric mean, a proper geometric mean. So if you don't form one, you know you messed up and you have to try the other triangle, okay? So here we have the big triangle. We're given its hypotenuse and a leg, okay? So that's good. Now, you're like, what are you talking about? We don't have a leg, it's x. But that's what we're looking for, so that's fine. So we can say that we're going to compare the big triangle, okay, and we're going to compare the hypotenuse over, that looks like the short side to me, over the short. The hypotenuse is going to be 12 plus 4 over the short side, which is x. Now we have to look here at the small triangle because it has a shared side. The shared side is x. It shares with the big, so we're going to put x there. And then the short side we're going to call 4. That's what it looks like. The short side looks like it's 4. We have a geometric mean there, so that's good. Okay, there's our geometric mean. So we're going to say that, let's use red. We have x squared equals 16 times 4. 16 times 4, I believe, is 64. 16 times 2 is 32, times 2 is 64. We're going to take the square root, so we get x equals 8. So we have our first measurement, but notice we have y now, okay? So we have y. Y is a part of which triangle? Well, y is a part of 2 different triangles. Y is a part of the medium triangle and also the small triangle. Anytime we're comparing the altitude, okay? So here, the altitude. The only time we're comparing the altitude is when we have the small and medium triangles. That's another way to think of it, okay? Small and long side. Anytime we're looking at the altitude, okay, think altitude, we're comparing small to medium. So we have our altitude here, it's y. And let's compare the small triangle first, okay? And we're going to compare the long side to the short side. We already have the short side, okay? The long side is y, it's our altitude. Altitudes always get compared with the small and medium, okay? You can even write that here. Anytime we have the altitude given, okay, altitude. So we have y over our short side, which is 4. Now, we're always going to be comparing the medium triangle to that, so we have our medium triangle here equal to, now our long side is 12 for the medium triangle, and our short side is y. Okay, there's our geometric mean. Hope you guys see that. So we're going to do y squared equals 12 times 4, which is 48. So we take the square root. So y squared equals, y equals the square root of 48. I'm not going into simplifying this yet. You could just take the decimal form of 48. It's going to be almost 7. Okay, so it's almost going to be 7. It's going to be 6.9 or something like that. Okay, but this is fine for now. So square root of 48. Let's move on to our last example. Okay, let's go ahead and see which measurements we have. I'm going to highlight the big. I'm going to highlight the medium. Medium is purple. Okay, so the medium, and then I'm going to highlight the small. Okay, so I'm going to look here, and it looks like I have 2 measurements here of the big. So I always like starting at the big, I guess. So the big triangle, I'm given the hypotenuse. How do I know that's the hypotenuse? Because I look here at the 90-degree angle, and I see 5 and 4 are opposite that. So with my big, I'm comparing the hypotenuse, which is 9, over, okay, and then this looks to be my short side over x. And that's my short side. Now, if I'm comparing my short side, that means I'm going to be comparing my small triangle. So there's my small triangle. My hypotenuse is x, okay, because remember, what I compare on the left, I have to compare on the right. And my short side is 4. So I set those equal, and I get x squared equals 36. That's after I use cross multiplication. I should have changed the color. Gosh darn it. So I use cross multiplication, geometric mean. Okay, that's the whole point, geometric mean. Okay, and I get x squared equals 36. X is going to be equal to 6 after I take the square root of both sides. Okay, so done with x. X equals 6. This is very similar to my other one. Here I have y. That's an altitude, so I know I need to compare my medium and small. With my medium triangle, that y is my short side. So let's compare my short side to my long side this time. So my short side is y, my long side is 5, and this is going to be equal to my small triangle, where the long side is what? What's my long side? My short, no, sorry, I'm comparing short to long. So my short side is 4, and my long side is y. I have a geometric mean again right here, so I get y squared equals 20. Take the square root of both sides, and I get y equals the square root of 20, which is between 4 and 5. Okay, and that's how I do these problems. Again, altitudes, compare small to medium, long, short side. Anytime there's hypotenuse, you're going to be comparing big to small or big to medium. And hopefully this will be helpful. Stay tuned for more tutorials to come. Thanks for watching. I hope you enjoyed this video.